Okay, so next project is dealing with the ultrasonic sensor with the buzzer. So in this project, we will be using an ultrasonic sensor and with a buzzer. That means we will set a threshold. If the object is uh, in that particular limit, then the ultrasonic sensor will send a signal, and the Arduino will trigger the buzzer so that the buzzer will produce a sound. Uh, for example, in the case of sensitive area, for example, one particular person is trying to enter into a sensitive area, that sensor will sense that object and alert the security systems, alert the security people that an object is entered into that restricted area. And another example is, for example, a car. Okay, when I am parking my car, so I'm trying to park my car, then the buzzer will produce a sound if an object is detected. So that I can safely park my car safely. So these are some of the applications of ultrasonic sensor with the buzzer. So this when an object is detected within that particular threshold, the buzzer will produce a particular sound. So that is what is called ultrasonic distance measurement with buzzer alert using Arduino. So to start this project, we need the components such as Arduino. This is to program our project. Ultrasonic sensor is used to sense the particular object using sound waves, ultrasonic sound waves. That is the sound waves, the frequency is more than 20 kilohertz. Buzzer is used to produce the sound, and jumper wire is used to connect it. Breadboard is used to connect everything. In order to give a visual feedback, we can use LEDs, but that is optional. Power source is required, 5 voltage supply, or we can use Arduino's USB connection to power this circuit, power this project. So ultrasonic sensor, typically the HC SR04, and this ultrasonic sensor will send the sound waves. And when these sound waves hit a particular object, then these sound waves will reflect back, and the receiver will receive this sound waves. Then the time taken for the echo to return helps calculate the distance of the to that particular object. The time to return this echo signal, calculate the time using the equation uh, distance is equal to time into the sound of the speed of the sound. So using that particular equation, calculate the distance. Arduino will trigger the transmitter, and the transmitter will send the ultrasonic sound waves, and it will hit the particular object, and the echo signal. The receiver will listen the echo signal, and based on that threshold we provided in the program, the buzzer will be activated. For example, if I give the predefined threshold as 10 centimeter, so when the object is below the predefined threshold, then the Arduino will trigger the buzzer so that the buzzer will produce a sound alerting the user to the presence of an object. So this is the circuit diagram. Okay. So circuit diagram, this is my ultrasonic sensor. So this is my sensor. This is my ultrasonic sensor, and this is my buzzer. So here this ultrasonic sensor will detect the presence of an object. Okay. And we uploaded the program into the Arduino. So based on the distance of the object, and based on this program, this buzzer will produce sound. That is the symbol working behind this project. So the connection is basically similar to the previous project. Here in the ultrasonic sensor, we have the VCC ground. VCC is connected to the 5 voltage. VCC is connected to the 5 voltage. Okay. This is VCC. This VCC is connected to the 5 voltage, and this ground is connected to the negative. That means ground. And the trigger and the echo signal. So trigger is connected to pin number 9, and the echo signal is connected to pin number 10. So you can use any pin number. But here in this program, I'm using, you can use D8, D7, D6, D5. You can use any pin, but you have to change the pin number in the program accordingly. So which pin you are using, the same pin you should use in the program. So here I'm using pin number 9 and 10 for the trigger and echo signal. Then coming to the buzzer, there are two terminals. One terminal is connected to the negative, that means ground, and the other terminal is connected to the pin number 7. Okay, I'm connecting one terminal of the buzzer to the pin number 7, and another terminal is connected to the negative terminal is connected to the ground of the Arduino. So this is the connection. Coming back to the simulation, I'm showing the simulation. So here in this program, so I'm checking the code. So here in this code, I'm just enlarging the size. Okay. So this here the distance I'm giving is less than 10 centimeter, and digital write buzzer pin high, else digital write buzzer pin low. So this means if the distance is less than 10, the buzzer pin high. High means the buzzer will produce a sound. Otherwise, else, if the distance is more than 10 centimeter, then the buzzer pin low. Low means off. So this buzzer is off. Okay, so distance is calculated using this equation. Distance is equal to duration into 0.034 divided by 2. So based on this equation, so this duration is the time to return the echo signal from the object to the receiver. Then using this equation, distance is equal to duration into 0.034 divided by 2, calculate the distance. And then we will compare this distance with the threshold, predefined threshold, that is 10 centimeter. Then based on that, either the buzzer pin high or low. So this 500 half second is used for the step stable. Okay, once one sound is produced, then half second delay is required to stabilize the buzzer. Okay, so next I'm going to show the simulation. Okay, so I'm clicking the start simulation. Okay, now you can see the distance is and this circle represents the object. So this is my object. Okay, and this is the object, and this distance is 57.4 centimeter, but our threshold is 10 centimeter. Okay, if this object is here, this distance is less than 10 centimeter, then the buzzer will produce a sound. So I will show you. I will move this object. So I am moving this object, and here you can see, the distance is reducing 53. Okay, I'm moving this object to less than 10 centimeter. Okay, now it is 26, 24 centimeter. Okay, 10, 20 centimeter, 19, 16, 15, 14, 12, 10. Yeah. Now you can see, you can hear a sound, right? So this is the sound produced by the buzzer. Means the distance is less than 10 centimeter. That means the distance is 8.6 centimeter. So if the object is below the predefined threshold, then the buzzer will produce a sound, so that will alert the user. If an object is entered into a particular, for example, a restricted area, if a particular person enters a restricted area, then that system will alert the security people, so that they can check what happened to the that particular area. Similarly, this is applicable to the parking of the car. When I'm going to park my car, then the sensor will sense if any object is there, then the sensor will produce a sound that will alert me to safely park my car. So go to the schematic view. As I already explained, this the connections and everything. So this is the connection. And go to the list of items. I'm using one Arduino. I'm using one ultrasonic distance sensor, 4-pin ultrasonic distance sensor, and also a piece of one buzzer also I'm using to produce the sound. Okay, so try this project, and you can change the distance or change the program based on your application, and you can check the output by clicking the start simulation. Thank you.